Good evening, and thank you for joining us for this live streamed presentation, The Spring Equinox with Laura Marseglia. I'm Jonah Miller with the Pajarito Environmental Education Center, or PEEC, located in Los Alamos, New Mexico. I'll be the moderator for today's talk. Tonight's talk is being recorded. We're able to offer programming at this time because of our wonderful members and donors. So we'd like to thank you for your continuing support. Laura is currently a student at Northern New Mexico College and will receive her degree in radiation protection in May. She discovered her interest in astronomy at Drew University in Rhode Island, and aspires to share her fascination with the cosmos with you as much as possible. On that note, take it away, Laura.
Thank you, Jonah, and thank you everyone else for tuning in. Let's get started here. So tonight I will be talking about the spring equinox. And here's an overview of what I'll be talking about tonight. The technical aspect of what is the equinox, and then a lot about how it's celebrated. So the equinox is a Latin word, which means equal night. The length of a day is 12 hours, and the length of nighttime is 12 hours. This year it's tomorrow, early in the morning. And another word for it is the vernal equinox. And so I included these pictures to show that if you were standing on the equator at noon tomorrow, you would see objects as if they had no shadow. And as you can see here with the parking meter, they do have a shadow. It's just straight down, which I think is really cool. The other equinox is the autumnal equinox, which happens in autumn. And then the other points of interest during the year are the summer solstice and winter solstice. So why does the equinox happen? It's due to the Earth's tilt on this. So the axis is the imaginary kind of line that the Earth spins around every day, and it's not straight up and down compared to its orbit around the sun. It's actually tilted. We can get into why later, but it has to do with when the Earth was forming, and along with the rest of the solar system. And long story short, the tilt of the axis causes the season. And so this picture illustrates just that, right? So which one are we? Oh, this one here. So this is the spring equinox, and you can see here that both hemispheres are facing head on to the sun. Whereas here for the summer solstice, the northern hemisphere is getting a lot more of the light compared to the southern hemisphere from the sun, and it's the opposite for the winter solstice. And then the autumnal equinox is the same as the spring equinox, where both hemispheres are facing the sun in the same proportion. Let's see. And another cool thing to note is a thing called the ecliptic. This is the line that all of the planets and the sun follow across the sky. So if we switch to, stellarium here, we can see that the sun, so here I have the date set to tomorrow. Let's see, here we go. This is noon tomorrow. And you can see here that the sun is on the celestial equator, which is 0 degrees. So that's how we can tell that the equinox is occurring, because the sun is at 0 degrees in the sky. Now, all of these grid lines come from throwing out, or what's a better way to say it? imposing the grid lines that we use on our maps onto the sky, right? So the same coordinates that we use for maps of the Earth, we also put those onto the sky. And so that's how we are getting these numbers here. Now, let's see. Another interesting thing is that if we move time here, so let me advance time, we see the sun go up above this 0 degree line, right? So now we're April, May, and then we peak about a little after mid-June, right? So here we can see that the sun is about 23.5 degrees above the equator in the sky. And that 23.5 degrees comes from the Earth's axial tilt being 23.5 degrees, right? So if we keep advancing time, we see the sun start to go back down, and then we hit the autumnal equinox here in September. And then if we keep going down forward in time, right, we see the sun going down. And that's because the northern hemisphere is being tilted away, right? So if we get to the winter solstice, right about here, we can see that the sun is at a very low point in the sky. And then get to about another year later, we see that we are now exactly a year away from tomorrow, and that is the spring solstice again. So now we're back at the celestial equator. So that's what I wanted to show here in this picture, is the shape that the sun makes over the course of the year. It's called an analemma. So what happens due to the equinox happening, right? What changes do we see on Earth? It all has to do with the progression of seasons, right? So we see a lot of things happening that we associate with springtime, right? The Earth starts to get warmer, temperatures start to get warmer. We see lots of new plants starting to grow again, like the crocuses and daffodils and things like that. Animals are coming out of hibernation again because it's warmer. Birds and other migratory animals will do their migration patterns. Another interesting thing that I found is that the ocean currents will start to, I said the opposite in my slides here. The ocean currents will start to kind of become less strong. And that's because, well, you can see here that during the winter, when everything's cold, the currents here are stronger, right? And that's because of temperature patterns. In wintertime, there's a lot of nutrients that are being stirred up, but there isn't a whole lot of sunlight. So in spring, when a lot of those nutrients are still there, and then the sun starts to become more prevalent, you'll see an explosion of phytoplankton in the oceans, which I think is really cool. And then that'll start to die off as temperatures get really warm, summertime. And then in fall, when the Earth starts to cool off a bit, the cycle will start again, which I think is really cool. Another thing that happens in spring is that we get more rain. And again, this has to do with temperature patterns, right? So as the Earth starts to warm up, the atmosphere near the surface of Earth will absorb more heat from the ground. As the ground starts to absorb sunlight, then it'll transfer to the atmosphere. But the jet streams in the upper atmosphere are still cold. They're less dense and they can't absorb as much heat. So when these two layers of atmosphere collide, they create really strong storm fronts, which is why we see so much rain in springtime compared to other times of year. And like I talked about, the temperature of Earth, or of each hemisphere rather, starts to change. And to show this here, I'm looking at the solstices, right? So over here on the left is the northern summertime, right? And the caption says southern winter. They're opposites. And then on the right, it's the northern wintertime. And you can see here that the angle at which sunlight hits the Earth is more direct in the northern summertime and less direct in the southern wintertime. And then it switches for the other solstice. But so what's happening right now for the equinox is kind of like this picture, where both hemispheres receive light at the same angle. That's all I wanted to say about that. So now let's talk about how the equinox is celebrated across the world. So going back in time a little bit here, Easter, right, the Christian holiday Easter, comes from a pagan holiday called Ostara. Baskets full of eggs were offered to their deity Eostre, I think is how you say it. And the eggs were to symbolize fertility and new beginnings and things like that. And the name of the deity sounds like Easter, right? How the Christians kind of made that name. And so Easter is always the first Sunday after the first full moon after the spring equinox. So that's why it changes so much every year. It all depends on the full moon. And so the traditions that Christians have, like coloring eggs and, you know, the symbols of like the Easter bunny and filling baskets and things, those are all adopted from Ostara, the pagan holiday. And so I thought that was really cool that that's to find the origin of those traditions and symbols. I thought that was cool. So anyway, going now to traditions that are still celebrated today. I'm going to go through a whole bunch here, starting with China. It's a tradition for them to balance eggs. It is a myth that on the equinox, everything's balanced, and so you'll be able to balance an egg. That's a myth because you can do it any day of the year. But that tradition has still held, even in the face of science. And another thing that Chinese people will do is they will feed cows sticky rice balls for good luck. And another symbol of luck is if you see geese flying back north within the first 5 days after the equinox. It's said to be good luck. Iran, they use the Persian calendar. And so for them, the spring equinox marks the first day of New Year in the Persian calendar. That celebration is called Nowruz. I've also heard it been said as Nowruz, but it means new day. It's a 12 or 13-day celebration, which involves buying new clothes for family, cleaning house, and as you see here, the centerpiece in terms of food is wheat and lentil shoots which their name literally translates to green shoots. So I found a YouTube video here that I wanted to play that kind of goes more into talking about, here we go. Let's make this big.
Nowruz literally means new day, and it's symbolic of the fact that it happens right when the spring equinox happens. So that was just showing other aspects of the celebration. Apples seem to be a common theme, as do eggs, and of course, flowers. Moving right along here. In the beginning of this part, we talked about Ostara, celebrated by pagans from a long time ago, but modern pagans will often celebrate at Stonehenge because of Stonehenge's kind of set up for the equinox and solstice and other astronomical features. So at dawn, people will watch the sunrise. They will have drinks that are said to cleanse their blood, and they will play musical instruments that date back. Let's see. In Turkey, Turkey is very similar to the Nowruz celebration, but in addition, they also focus a lot on fire, jumping over fire, and bonfires, and again, wearing new clothes, flowers, celebrating with song and dance, and smashing pottery, sorry, oddly enough. In Siberia, again, cleaning houses, making peace with everyone, beating drums, that is supposed to symbolize greeting spring and leaving winter. For Mexico, they focus a lot on the Mayan culture. This one down here is a temple that is supposed to, in the shadows here in the steps, resemble feathered serpent that was their deity. And to celebrate, they also like release butterflies, to celebrate with food. And over here, this is a picture of Teotihuacan, where people will dress in white, climb this large pyramid of the sun. And I wanted to play a clip from there as well. So there we go. And lots of like wearing white, lots of bringing cleanliness into the spring. In Egypt, this mythology story dates back to ancient Egypt, so in spring, the Nile River would always rise and flood. And so I wanted to show the difference between the Nile in, say, the fall versus the spring. And so that comes from a myth that has Osiris, who was the king of Egypt, and Isis. Now, Isis was the queen of Egypt, and she was also known as a healer. She had powers to cure the sick and bring dead things back to life. So Osiris and Isis are married, and they are the king and queen of Egypt. And Isis was kind of depicted to be the quote unquote ideal woman for back then, who kind of blended in with the background when things were fine. But when people ran into trouble, she would emerge from the background and help out. So, so her ferocity is represented by the dog star, which is known as Sothis in ancient Egypt, which we now know today to be Sirius. And I've also seen things where she is depicted as Orion. So the myth goes that Osiris and Isis were queen and king and queen rather, respectively. But Osiris's brother, Set, was jealous and he wanted to be king. So he murdered Osiris, but Isis was able to revive her husband, but not totally. He was a mummy who eventually progressed to the afterlife. And the Nile flooding is said to be Osiris's tears from being condemned to the underworld, and that he can't be with Isis. And another part of the myth is that before Osiris had to leave for the underworld, Isis had a son named Horus. And so again, there is this theme here of Isis bringing life from death. And that's what springtime is all about. In Japan, their spring traditions are influenced by Buddhism. They remember their ancestors by lighting incense in cemeteries, and they'll also like replace flowers, clean the gravestones, leave offerings of incense, and also food is very common as well. And other kind of related holidays are Passover, the Jewish holiday Passover, but also Holi in India, which has to do with large bright colors, music and dancing, and the mythology is that good overcomes evil. So there are, lots of main themes here, right? That spring represents a fresh start, like cleaning house and getting new clothes and stuff, bringing life, like the warm blooming spring from death and the cold of winter, and that same kind of warm good overcomes the cold evil. And then of course the fertility and new beginnings, as seen with like eggs and apples and things like that. So how can we celebrate? It's kind of hard to go to, big, huge celebrations like I've talked about. Everyone's kind of had to adjust a little bit. So what can we do while still staying safe this year? We can start a garden, be it flowers or like veggies, doing spring cleaning, and starting fresh. That is huge, and it'll also probably help to bring in some kind of fresh air. I also recommend going outside, maybe hiking, although watch for snow and mud this time of year, stargazing, bird watching, and then dyeing eggs and maybe making spring baskets of candy and other, favorite foods, and maybe even a whole feast. It's a great way to support farmers markets and other locally sourced food, and to stay really connected with nature, which is what springtime is all about and what the spring equinox symbolizes. So with that, this was kind of a quick presentation, but I am open to questions if you guys have any.
So as a reminder, please type your questions into the chat and I will relay them to Laura. While people are thinking about that, maybe I'll start with a couple. So Laura, you mentioned that you could talk more about why the Earth is tilted. Do you want to revisit that?
Yeah, definitely. So I mentioned that here. So the Earth's axis is tilted because it all has to do with when the Earth was forming, and the whole solar system, in fact. So the solar system was very tumultuous in its early days. The order of the gas giants was not the order that we see today. There was a lot of kind of moving around. And that moving around shifted the gravitational almost hold points of like what we know as Lagrange points, where there's kind of a well in each orbit for like where telescopes are in Earth's orbit. Back in that period of formation, there was a lot of debris. And so as the orbits of the gas giants kind of shifted around, that caused the debris to fall out of orbit. And so as it came towards the sun, some of it got stopped by Earth. And so some of this debris in the form of rock was very large, almost the size of another planet.
And so when that collided with Earth, that skewed, it was such a forceful collision that it skewed the Earth's axis, right? It knocked the axis to the side a little bit. And so this period is called late heavy bombardment, when all of this debris from the outer planets fell into the inner solar system. And so this is how the moon was formed. And then the moon, once it formed, helped to stabilize the Earth's axis. So that's kind of how it stuck at that 23.5 degrees. So, and then you can see it on the moon as well. The huge craters in the moon's surface are also from the late heavy bombardment period. And you can see in a picture of the moon how one face is much more pockmarked than the other after the moon became tidally locked. And now I'm kind of going off on a tangent here. But I hope that answers your question.
Yeah, that was helpful. That's cool stuff. Thank you.
Yeah.
So I see a question from Stephen Becker. On the Siberian slide, what was the wolf picture about?
That was kind of just showing a wolf, and he has an apple here. And I wanted to show that wolves are a important part of the ecosystem in that part of the world, and also how prevalent the apple imagery is for spring.
And Arlene has a question, which is Chaco Canyon site has light shine on, let me try to interpret this. The question is about the Chaco Canyon site where light shines on petroglyphs. And the question is, does it shine on the petroglyphs on the spring equinox? And also, do Celtic burial sites do the same?
I see. Okay. So I'm going to be honest. I totally forgot about Chaco Canyon. I'm really sorry. I know that's super important in terms of archaeoastronomy. So I don't know enough to be able to speak about that. But I do remember seeing something about Celtic, something in that those traditions having to do with the spring equinox. I'm really sorry that I can't give a better answer here. I don't remember enough about it to be able to say.
Well, let's just leave it as an exercise to the viewers then, as a cool New Mexico thing, especially.
Yes.
I have a question from Lonnie and Lisa. They both asked the same question, which is, can you go back to the figure with the infinity symbol or the figure 8 of the sun's path? And can you go back and explain again how it relates to the sun's path? And in particular, are those noon points seen from where, and what did you call this thing?
Okay, yeah, so this is an analemma. And I didn't put it in the slide. Oh gosh. But here, let me go back to stellarium. So we get these grid lines from superimposing Earth's grid lines into the sky, right? So that's why this 0 degree celestial equator is at, oh, that is not helpful. But it should appear in the sky at the latitude we are on the Earth, right? So what's our latitude here? about, what is it, 40 degrees maybe, then the celestial equator should appear 40 degrees above the horizon, right? So from the celestial equator to the horizon should be about 40 degrees, and then the 50 degrees should be between the equator and straight up. So so for the spring equinox, at noon, right? So that's, if we go back, it just moves it across the, okay. So we should see, right, that at noon on the equinox, the sun is at 0 degrees, right? So if we go back in time a little bit, this is still, let's see, this is still noon, right? But we've gone back about a week or so, and we see that the sun is a little below the celestial equator, right? And then if we go forward in time, right now we're about a month out, month and a half, we see that the sun is significantly above the celestial equator. So the equinox marks when the sun reaches the equator, the celestial equator, right? And so if we keep advancing time, we see that the sun keeps rising in the sky, and at about the summer solstice, right, which is 3 months from now, we see the sun hit its highest point in the sky, right, which is 23.5 degrees. And that has to do with the Earth's tilt, right? And so it's so high in the sky because of Earth's tilt. And that's why it gets so hot in summer, because, right, if we go back to the other diagram I had, this one, the sunlight is a more direct, angle? Like, it comes in and has to pass through less atmosphere, right, in order to reach the surface, where in the winter you can see it come in at a shallower angle, so it's less direct, and so that's why it's hot in summer. And then anyway, so if we progress time again, we see after the summer solstice, the sun starts to fall in the sky, right? And so we advance time to mid-September, and we are back where the sun is on the equator again, and that's the autumnal equinox, right? That happens about here-ish, September 22nd or so. And then we keep advancing time, October, November, we see the sun falling again in the sky, and to get to its lowest point about mid-December. And this is the winter solstice. And then we advance time back to March, mid-March again, and we are back having another solstice. So an analemma, right, is if you, let's see, take a picture at the same time every day, from the same place, right? And if you put those all on top of each other, you will see this pattern start to emerge. So right, so here, right in the middle where the two kind of intersect, those are the equinoxes. And then up here, up top here is the summer solstice, because that's when the sun is highest in the sky. And then down the bottom is the winter solstice, because that's when the sun is lowest in the sky. I hope I did a better job of explaining it.
Yeah, thanks.
Awesome.
The fact that you can actually, something that always amazes me about photography is if these time-lapse photographs of basically anything always kind of reveal something very cool.
Yeah, there's patterns everywhere in nature. It's really cool.
And so I have one, Steve Becker has a comment that the angle is actually 90 degrees, our latitude, which is 36 for the sun's altitude on the equinox.
Okay, thank you. Yes, I didn't know the exact number.
And Rick, and relatedly, Shoban, one of the PEEC organizers, mentions that she wants to do an exhibit about the Analemma outside by the PEEC sundial, and solicits, I think, you in particular for ideas, but I'm sure that suggestions from the community would also be welcome. So if you have some feedback for that, please let us know and put it in the comments when you have the survey, or reach out directly if appropriate. And I see a correction about Chaco Canyon from Rick Wallace. It is the Casa Rinconada with which the sun, the window in Casa Rinconada in Chaco Canyon that the sun aligns with. And I can put a link to the Wikipedia article for that site in the chat here. So I have a question from Susan, who asks, why is the apple important during the spring equinox? They're harvested in the autumn.
I know that occurred to me too. I don't know where it comes from. It didn't cross my mind to look it up. I just had I'd seen it a lot. And so it seemed like a trend, but I think it has to do with new fruit and things like that. And it seems like it would be more of a recent thing because of mass producing food a bit more. But I can't say for certain where it comes from.
Interesting. And then I'll inject a question of my own here,
Sure.
kind of related to the same thing, is the connection of egg, the egg metaphor seems pretty universal cross-culturally.
Yes. Yeah.
And, you know, I suppose this makes sense as far as it's just sort of new life. But I still found it kind of surprising that it was so common. Do you have any comments or, you know, thoughts as to why that might be?
I agree with you that it makes sense that it's the symbolism from it can be interpreted the same way. And I think why it's so prevalent in so many different cultures speaks to our interconnectedness, right? That we all kind of started from the same place, and that's why we have a lot of the same ideas, right? And so that even though we can be so different in so many other ways, that the fact that a lot of these traditions are very similar says a lot about kind of where we started.
Yeah, I like that. I see a correction from Rick about the apple blossoms. They come out in spring, so many cultures associate them with the new life and fertility.
Aha, the blossoms, I see. That makes sense.
Yeah, so it's when they blossom. Yeah, Susan, I think, also mentioned the blossoming, but she, okay. Well, I don't see any more questions in the chat. If you have any more, now is your last chance to ask them. I'll give you a moment to do that while I mention that you can find more PEEC content on the web at our website, peeknature.org. And there are also many of these talks from the past have been recorded, and they are on our YouTube channel. I don't see any more questions, so I guess at this point, we will call it. Thank you so much for sharing with us tonight, Laura. Thanks again for tuning in. Thanks again, Laura, and have a good night, everybody.